Section 2.8, combining functions and composite functions. So we're going to be talking about two things in Section 2.8. The first thing is combining functions. So taking two separate functions and combining them by addition, subtraction, multiplication, or division. So what you see here is just simply the notation that you may see. Okay? When you see f plus g, that simply means you're going to take your f of x function and add it to your g of x function. So you're going to combine those two functions with addition. Okay? So again, all of these are just notation. Okay? Making sure you're familiar with what the question's asking. So if you see f divided by g, okay, down here, f divided by g, they want you to take your f function and divide by your g function. I like the notation on the right-hand side, actually with the f of x and the g of x written out. I think it makes a little bit more sense, but you're going to see both notations. The second part of this section deals with composition of functions. So it's taking two functions and putting them together. So if you think about it in terms of a function machine, it's like we're going through one function, and then we're taking that answer and going through another function. Now, there's three ways to see that you might see this written. So the first is, it's not fog, it's f of g, f of g. You might see f of g of x, and then this last one is also f of g of x. That is my favorite notation because I think it makes the most sense. But you need to be familiar with all three notations. Now, we also could have g of f. That is different than f of g, okay? It's a different composition of the functions. After we compose functions or put two functions together by composition, we're going to find the domain. Remember our rules for domain from before, okay? The two things that we have to look for in terms of domain are, one, we can't have 0 in the denominator, and the second thing is that we can't have a negative radicand. Now, when we find the domain of our composition function, that really means we're going to look at the new function that we have created. We're going to find its domain. But then we also must look at the domain of the inside function. So we have to piece together the domain of the inner function, which, going back up to this example, is the g of x. Okay, this first notation, the inner part is the g of x. And then we have to look at the combined function. And we'll get to that as we go through some examples. Example 1, find the requested function and state its domain. All right, so when we look, they're asking us to find f plus g. And again, I like to write it as f of x plus g of x. So I'm simply adding these two functions above together. So f of x is x minus 3 plus g of x is 3x minus 5. And yes, I put them in parentheses, but you don't need to. And then from here, I'm just going to combine like terms. So I have an x plus a 3x, which is going to give me 4x. And then I have a negative 3 plus a negative 5, which is going to give me a negative 8 or a minus 8. So my combined function, by adding these two together, is 4x minus 8. Now, it also asks us to state the domain. Remember, my two restrictions for domain, I have to look at denominators and radicals. Well, there's no denominator here, and there's no radical, so my domain is simply negative infinity to infinity, all real numbers. I can put any values in for x, and I'm going to get an output value. For part B, we're going to subtract function f and function g. So f minus g, and again, I like to write it as f of x minus g of x. Okay? My f of x function is x minus 3 minus my g of x function is 3x minus 5. So slightly different than adding them. We have this minus out here. Okay? This minus needs to be distributed to both terms. All right? That's going to leave me with x minus 3. That remains unchanged. And then minus 3x plus 5. Okay, I have to distribute that negative since I'm subtracting. Now I'm going to combine like terms. I have x minus 3x, which gives me negative 2x. And then I have negative 3 plus 5, which is going to leave me with a positive 2. So my answer is negative 2x plus 2. Now, again, it wants to know the domain. I see that there are no restrictions, no denominators, no radicals. So my domain, again, is negative infinity to infinity. Part C, we're going to find f times g. Okay, and again, I'm going to write it as f of x times g of x. So my f of x function is x minus 3, and I'm multiplying that by 3x minus 5. So I have a binomial, 2 terms, times another binomial, and to simplify that, I'm going to FOIL, okay? So first, x times 3x is 3x squared. Then outside, x times negative 5 is minus 5x. And then inside, negative 3 times 3x is minus 9x. And last, negative 3 times negative 5 is negative 15. Combine like terms, and I'm left with 3x squared minus 14x minus 15. So that is f times g. Again, domain, no restrictions. So my domain is negative infinity to infinity. All values can be substituted in for x, and you will get an output y value. Part D, f divided by g. So I'm going to take my function f of x and divide by my function g of x. That's going to leave me with x minus 3 in the numerator and 3x minus 5 in the denominator. And it's as easy as that. There's no simplifying in this. Nothing simplifies. So my answer is simply x minus 3 divided by 3x minus 5. Now for domain, if you look, we do have a restriction. We have a denominator. Remember, when you have a denominator, we need to take that denominator, 3x minus 5, and we need to set it not equal to 0. We cannot have 0 in the denominator. Now we solve that. So I'm going to add 5 to both sides. That leaves me with 3x cannot equal 5. To solve that, I'm going to divide both sides by 3. So x cannot equal 5/3. Now, we always write our answer in interval notation. So x cannot equal 5/3 means every value except 5/3. And the way we write that is negative infinity to 5/3 union, and we pick back up where we left off, 5/3 to infinity. And that is the domain of this new function. Part E, this time we're going to find g divided by f. Okay, notice it's different. We have them in a different order. So I'm going to take my g function, which is g of x, divided by f of x this time. G of x is 3x minus 5, and f of x is x minus 3. Again, no simplifying here. Everything's simplified as far as we can. So that is my solution. We also need to state the domain. And just like the last one, I have a denominator, so I have to exclude a value. And I figure out that value by taking the denominator, x minus 3, and setting it not equal to 0. Solve that, and I get x cannot equal 3. And now I need to write that in interval notation. The interval notation is everything except 3, so negative infinity to 3, union 3 to infinity. Parts A through E in this first example were all examples of combining functions. Now we're going to look at composition of functions. Okay, so it says find the requested function and state its domain, same directions, but now we have f of g. F of g. And again, I like to write it in a different notation. I like to write it like this, f of g of x. F of g of x. So really, what they want us to do is to find f of, I'm going to take g of x right here, and I'm going to actually put the function in. The g of x function is 3x minus 5. So I took that g of x and I said, okay, g of x is actually 3x minus 5. Now, and I can have brackets or parentheses. Now, f of a function tells us to take whatever's in here and plug that in to my f function. So I'm going to take 3x minus 5 and I'm going to plug it into x minus 3. So I'm going to write it out down here. My f of x is x minus 3. So I'm going to take this, sorry guys, I'm going to take this and I'm going to plug it in for this x right here. So that's going to leave me with f of x equals, I'm going to take this x out and put the new stuff in, so 3x minus 5 minus 3. Combine like terms, that leaves me with 3x minus 8. So f of g is equal to 3x minus 8. All right, now let's talk about the domain. Remember, we have to look at our new function that we've created, which is 3x minus 8. There are no restrictions there. But then we also have to look at my inside function. My inner function was this 3x minus 5. Again, no restrictions there. Since there are no restrictions on the new combined function and the inner function, I have a domain of just negative infinity to infinity. For part G, we're going to do another composite function, but this time we're doing g of f. And again, I like to write it using this notation, g of f of x, so that I can clearly see what my inner function is. My inner function is right here, the f of x. Okay, so I'm going to take that f of x out and replace it with the actual function. So really I'm finding g of x minus 3. F of x is equivalent to x minus 3. What that's telling me to do is take this x minus 3 and plug it into the g function. Okay, so again, here's my g function. G of x is equal to 3x minus 5. So what they want me to do is take this x minus 3 and plug it right there for the x. So that's going to leave me with 3 times, I'm going to take the x out and put the new stuff in, put x minus 3 in, minus 5. Now I have, when I distribute this 3 to both terms, I have 3x minus 9 minus 5. Combining like terms, that leaves me with 3x minus 14. So that is the composition function g of f. G of f. So notice that's different than f of g from our previous example. Now, domain. Again, in our new combined function, our new composite function 3x minus 14, there are no restrictions. My inner function back up here was x minus 3, no restrictions. So my domain is negative infinity to infinity. No restrictions, so all real numbers. And part H, this time we're going to do f of f. Okay, so composition of f with f. I like to again write it f of x. So this time, this g function isn't even in the picture. I'm going to go ahead and cross it out. It's not even in the picture. So what that's going to give me is f of, I'm going to take and put the f of x function in here, so f of x minus 3. So that means I'm going to take this x minus 3 and plug it into my f function. So let's write out my function. F of x is equal to x minus 3. So I'm going to take this x minus 3 right here, and I'm going to plug it in for that x. That's going to give me x minus 3. Again, I'm taking that x out and putting the new stuff in. And then I still have this minus 3 out here. When I simplify, I'm left with x minus 6. That is my new composite function. Again, no restrictions, so my domain is negative infinity to infinity. Example 2, let f of x equal 2x plus 1 and g of x equal 2x squared minus 3. Evaluate each of the following. So I have two new functions, a new f of x function and a g of x. And this time, I'm combining functions. I'm doing f minus g, but instead of x, I have this 1. Okay? And again, this is where the other notation makes a little bit more sense to me. So, I'm going to write it as f of 1 minus g of 1. Okay? F of 1 minus g of 1 is the same thing, just I think in a clearer notation. So let's look at what f of 1 is telling us to do. F of 1 means take 1 and plug it into your f function. So that's 2 times 1 plus 1. All right? Which gives me 2 times 1 is 2. 2 plus 1 is 3. So 3 minus something. Then over here, I'm going to do g of 1. I'm going to plug 1 into my g function. That's 2 times 1 squared minus 3. 1 squared is 1. 2 times 1 is 2. And 2 minus 3 is a negative 1. So I'm really doing 3 minus negative 1. 3 minus a negative 1 is a positive 4. Okay, so we can simply plug in 1 when there's or whatever value is given, and then we don't have to write it in terms of x anymore. B of example 2. Using the same two functions of f and g, this time we're going to find f times g of 2. And again, I like to write it like this. It's telling me to find f of 2 times g of 2. So do f of 2 and do g of 2 separately and then multiply those two answers together. So let's do f of 2 first. F of 2 means plug 2 into my f function. So 2 times 2 plus 1, which gives me 5. And then g of 2, 2 times 2 squared minus 3. Well, 2 squared is 4. 4 times 2 is 8. And 8 minus 3 is 5. So really, what I'm doing is I'm multiplying 5 times 5. So f times g of 2 is equal to 25. Part C, f divided by g of 0. Okay, so we're going to do f of 0 divided by g of 0. So I'm going to plug 0 into my f function, so that's going to give me 2 times 0 plus 1. And in the denominator, I'm going to plug 0 into my g function. So 2 times 0 squared minus 3. And then I'm going to simplify the numerator and denominator. 2 times 0 is 0. 0 plus 1 is 1. 0 squared is 0. 0 times 2 is still 0. And 0 minus 3 is negative 3. So I'm left with negative 1/3. Now we're moving on to a composition of functions. So let's look at what they're asking us for. They're asking us for g of f of 2. So I'm going to again write this in the notation that I prefer, g of f of 2. Okay? So you want to start on the inside. Start on the inside. So that means what I'm going to do is I'm first going to evaluate f of 2. Make sure you write these notes for yourself so that when you're looking back, you know exactly what you did. So f of 2 is equal to 2 times 2 plus 1. 2 times 2 is 4. 4 plus 1 is 5. So we know f of 2 is equal to 5. So what I'm going to do is I'm going to take my g of f of 2 and I'm going to rewrite it as g of 5 because I know that f of 2 is equal to 5. Now what that's telling me to do is to take 5 and plug it in for g. Take 5 and plug it into the g function. So that's going to give me g of 5 is equal to 2 times 5 squared minus 3. 5 squared is 25. 25 times 2 is 50. and 50 minus 3 is 47. Okay, so let's recap. Again, what this is telling us to do when I have g of f of 2, that's saying plug 2 into the f function and get an answer. Then take that answer and plug it into my g function. That's how the composition works. It's like I said before, going through two function machines. You go through one machine, spits out an answer, you take that answer and run it through the next machine. For part E, we're working with g of negative 3. So again, I'm going to rewrite it, g of negative 3. So again, we're going to start inside. We're going to find g of negative 3 first, g of negative 3. So I'm going to plug negative 3 into my g of x function. That's going to give me 2 times negative 3 squared minus 3. Negative 3 squared is a positive 9. Positive 9 times 2 is 18, and 18 minus 3 leaves me with 15. Okay, so again, I plugged negative 3 into my g function, and I got 15 out. Now I'm going to take that answer, which is 15, and I'm going to plug it into the next function, which they're telling us to plug it into g again. Okay, so now I'm going to have 2 times 15 squared minus 3. 15 squared is 225. 225 times 2 is 450. And 450 minus 3 is 447. So g of negative 3 is equal to 447. Example 3. Find f of g and its domain. So let's find f of g first. And again, I like to write it like this, f of g of x, which then tells me that I'm going to take my g function, g of x, and I'm going to plug it in to f. So I'm going to write that as f of 1 over x, because that's what g of x is equal to. So again, now that's telling me to plug 1 over x into the f function, okay, into the f function. So let's go ahead and do that. My f function, f of x, is 2 over x plus 1. So I'm going to take that x out and put 1 over x in its place. That gives me f of x equals 2 divided by 1 over x plus 1. Now, we can't leave it like that, okay? We have fraction inside a fraction, which is ugly, all right? So, what we're going to do is we're going to simplify this, okay? To do that, I'm going to multiply everything by x, okay? I'm going to multiply the top by x and the bottom by x, because that's my denominator here. So that's going to leave me with 2x on the top, and in the denominator, x times 1 over x, remember we have to multiply it by both of these pieces, it's going to leave me with 1, and then x times 1 is x. So I'm going to go ahead and write my function up here. F of g is equal to 2x divided by 1 plus x. Now, for domain, remember we have to look at two things. We have to look at our new function. Well, our new function is 2x divided by 1 plus x. I know that I have a restriction. My denominator, which is 1 plus x, cannot equal 0. When I solve that, that's telling me that x cannot equal negative 1. If it's negative 1, then it's undefined. But then remember, we also have to look at the inside function. Going back up here, the inside function is 1 over x. All right? So my inside function is 1 over x. And remember, I have another restriction. The denominator cannot equal 0. So I say x cannot equal 0. Well, I have to combine these two pieces. So x cannot equal negative 1, and x cannot equal 0. And what that means is when we write that together, it's everything except 0 and negative 1. So I'm going to go negative infinity to negative 1 and stop. Pick back up, so union. I'm going to go from negative 1 to my next stopping point, which is 0. Union. And then pick up where I left off, 0 to infinity. And that is the domain of this composite function. Example 4, find f of g and its domain. So similar to the last problem. So again, we're finding f of g of x. F of g of x. Which means we're finding f of 5 minus 2x. So I'm going to take 5 minus 2x and plug it into my f function. All right, so here's my f of x function, square root of x plus 4. So I'm going to take this 5 minus 2x. I'm going to plug it in for that x right there. So that's going to give me the square root of 5 minus 2x plus 4. Now when I simplify that, that's going to leave me with the square root of 5 plus 4 is 9, so 9 minus 2x. So my composite function f of g is equal to the square root of 9 minus 2x. Now I have to remember the second part is to find the domain. So let's look at my new function. This time I have a radical, and I know that whatever is under the radical, which is called the radicand, has to be greater than or equal to 0. So 9 minus 2x must be greater than or equal to 0. And so go ahead and solve that. So I'm going to subtract 9 from both sides. That leaves me with negative 2x is greater than or equal to negative 9. Then I'm going to divide both sides by negative 2. And that's going to leave me with x. I divided by a negative, so now it's going to become is less than or equal to negative 9 over negative 2, which is a positive 9/2. Okay, so that's the restriction from my new composite function. And then I have to always remember to look at the inside function. The inside function was 5 minus 2x. No restrictions there. So I only have to deal with this x is less than or equal to 9/2. And to write that in interval notation, that is everything from negative infinity up to 9/2, including 9/2, so it gets a bracket. Example 5. Express the given function h as a composition of two functions, f and g, such that h of x is equal to f of g of x. Now, this statement right here that h of x is equal to f of g of x is very important. Okay? So we know f of g of x, if we write it this way, that g of x is the inner function. All right, so what we need to do is we need to take this function h of x is equal to the fourth root of x squared plus x plus 1 and decide what we think the inner part is. Okay, and in my opinion, I look at this and I say, okay, the inner is what's under the radical. So I'm going to call the inner, which I know is g of x, x squared plus x plus 1. So that's my inner part. Now, remember, a composition of functions is taking g of x and plugging it into another function, f. So what am I plugging this into? Well, whatever I've decided is the inner function, then what's remaining is the outer function. So the remaining part is the fourth root of x. Okay, so my f of x is the fourth root of x. My g of x is x squared plus x plus 1. Example 6. Similar to the last one, we're going to express the function h as a composition of two functions f and g such that h of x is equal to f of g of x. So again, I know that I'm taking this function, I'm decomposing it. So it's going to be f of g of x. I need to, again, decide what the inner function is. When I look at this, what do I consider to be the inside? At first glance, I would say that the inside is x squared plus 3. So the next question is, what am I plugging that into? That would give me my f of x function. That would mean I'm plugging it into 1 divided by the absolute value of x. Now, With this one and many of the problems, there are alternate solutions. So I do want to give you another solution. So that's one answer. Now, another answer would be, all right, maybe you look at this entire composite function and you say, I think the inner part is absolute value of x squared plus 3. Then, what must my f function be? Well, what am I plugging that into? I would then be plugging that into 1 over x. So both of these are viable solutions to this problem. Okay, so keep in mind that you may come up with something different than your neighbor.